discuss now. Decoder. So decoder is a combinational circuit. Decoder is a combinational circuit that converts the binary information, from n inputs from n inputs to a maximum of to a maximum of 2 power n outputs, 2 power n outputs. Okay, to convert the binary information. Okay, to convert the binary information from n inputs to 2 power n outputs. That means the decoder will take n number of inputs and maximum of 2 power n outputs. Okay, so you can call the decoder as n by m decoder. N by m decoder. First one represents the input, second one represents the output. Okay, input and output, and here m will be less than or equal to 2 power n. M is less than or equal to 2 power n. So here you can call this type of decoder as n to m line decoder. N to M line decoder or N by M decoder. N by M decoder. Okay. So here N represents the number of input variables, whereas M represents the number of output variables. So what is the purpose of decoder means? Based on the given number of inputs, present input, output will be produced. Okay. It produces the output. And moreover, you need to remember one thing: n inputs, it will produce 2 power n outputs. But out of 2 power n, only one will be active. One will be produced. Any one of the 2 power n outputs will be active at any time. At any time based on the n value. Based on the n value. That means n inputs. For example, 2 inputs are there. How many outputs will be produced? 2 power 2, which is equal to 4. So this is called 2 to 4 line decoder. 2 to 4 line decoder. Next, for example, if you have 3. So how many outputs will be produced, ma? How many outputs will be produced? Am I audible?
8, ma'am. 8.
8. 2 power 3, which is equal to 8 outputs will be produced. But out of 8, only one will be active at any time. At any time, only one will be active. Okay. So one output only will be produced. But here the maximum outputs number is 2 power n. Is 2 power n. Okay. So now we will see the example of 3 by 8 decoder. How the decoder can be constructed. So for that we are having the two methods. The decoder can be constructed either with AND gate or NAND gate. Okay, the decoder can be constructed with either AND gate or NAND gate. So first we will discuss about the AND gate. The decoder 3 to 8 line decoder with AND gate.
Ma'am, with and Nando, ma'am.
Yes, yes, right. Okay. So first I'm constructing a circuit with AND gate. Okay. So how many outputs ma actually? 3 to 8 means how many outputs?
8 outputs, ma'am.
8 outputs, right? So I can take 8 AND gates. 8 AND gates. Each one represents one output. 4, 5, 6, 7, 8, right? So 8 outputs, and here each are represented as D0, D1, D2, D3, D4, D5, D6 and D7. Okay. So 8 outputs. For these 3 outputs, input connection should be there. So I can take the inputs, 3 inputs as A2, A1, A0. A2, A1, A0. Now, so in addition to these all things, you will have one more input called enable. Okay, to enable the circuit, to activate this circuit, to make it functional, this functional, will supply E value, E enable. Okay, so that enable is connected to all the AND gates, all the AND gates. Enable is constructed connected to all the AND gates. Okay, next. Right. So D0, D0. So D0 is the combination of all 3 inputs. So when it will be activated means if all the inputs are 0. If all the inputs are 0. 0 means here it is represented with complement. Okay. So I am taking A2 complement. Okay, first one. Next I am taking A1 complement because all should be 0, no? A0 complement. So this is the input. Okay. So how many inputs are there? A2, A1, A0. If all are zeros, D0 will be active. Okay. Are you following, ma?
Yes, ma'am.
Right. Next, D1 means what I need to write? D1 means 0, 0, 1.
Zero zero
0,
one
0,
ma'am.
1. So this 0, 0, 1 represents A2, A1, A0. Okay. You need to consider the same order. So A2 value is 0. So I can take from here A2. Next A1 value is also 0. A1 is also 0. 1 minute, ma. Next, what is the next one, ma?
0 1 0 ma'am.
0, 0, 1. This one is related to A naught. So I'm taking from here. Okay, A naught.
Yes.
Next, what is the next thing?
D2 is 0 1
0.
1 0.
Yes, D2 is 0, 1, 0. This 0 is related to which one, ma? A2.
A1 A2.
A2. A2. Right? So I am taking from here. Next, 1. This one is related to A1. So I am taking from here. Next one, 0. Okay? That is A naught. I am taking from here. Right? Is it clear, ma?
Yes,
Yes
ma'am.
ma'am.
Next, coming to D3.
One
D3,
One zero
0.
0.
1 0 0.
Huh? D3. D3.
0 1 1.
1
Yes.
1 ma'am.
0, 1, 1, 0. The 0 represents A2. So I'm continuing from this point. Okay. Next remaining are 1. So A1 is 1. Next one is 1. So I can take from here, right? Next one, D4. D4 is 1
One
double
double
0.
zero.
1 double 0. So A2 will be now 1. Remaining two are zeros. 0 means I can take from 1 minute, 1 minute. 100. So I can take from here. Next one, A naught 0. Next D5 101. Right?
Yes, ma'am.
Yes, ma'am.
D5 1011.
101.
One.
Right, I am writing 101. So for 101, A2 value is 1. Next. Second one is also 0. What is the third one? 1 again. Right? Next. What about D6 mark?
110, ma'am.
110. Okay. So this 1 is related to here. And next, second one. So here we are taking from here. And next one is 0. 0 means the third one here. Right. Next, all ones. D7 is all ones.
All ones,
Right?
ma'am. Yes, ma'am.
All ones. So I am considering this one. Next one, 1. And the next one is 1 here. Okay. So in this way, you can draw the circuit based on the input and output combinations. So for example, if I give A2, A1, A0 inputs are 110. So out of 8, which output will be produced, ma?
A1, ma'am.
D6.
D6, ma'am.
D6, right? D6 will be activated. Okay. So that means at any time only one output will be produced. Only one. If D0 is produced, others will be in the idle mode. Idle. Because we are having the inputs to all the things. But based on the input combinations, only one output will be active. One output will be raised. Is it clear, ma? Yes, ma. Is it
Yes, ma'am.
clear?
Yes, ma'am.
Right. So, from this you can draw the truth table. So, I am writing the truth table for decoder. So, what is truth table, ma? Fast, fast. What is truth table? What happened? Till now, no one listened about the truth table. Am I audible? Yeah, truth table is the tabular representation of the inputs and possible outputs. Okay. So here, what are the inputs for the decoder? What are the inputs, ma? Fast. What are the inputs?
A0, A1, A2.
Yes. And the outputs are
D0 to D7.
This.
right. So to make the circuit active, we are considering one more variable called enable E. Enable E. So, and the inputs. Okay. Based on the E value, the circuit starts working, right? Based on E value, the circuit starts working. So, inputs are A2, A1, A0. Next, the outputs. So, the outputs you can write it as D7, D6, D5, D4, D3, D2, D1 and D0. Okay. Now, if E equal to 0, if E equal to 0, what will happen? 0 will be supplied to all the gates, right? 0 will be supplied to all the gates. So, if enable equal to 0, no gate will accept the inputs. No gate will accept the input. So if it is 0, it will be in the not in functioning mode. Functioning mode. So all the outputs are also 0. Okay. All the outputs are also 0. Next, if E equal to 1, it is telling that it is in the functioning mode. Okay. E equal to 1 means power will be supplied to all the gates in the circuit and inputs will be taken. Right. So if E equal to 1 and all the inputs are 0, what is output? What is output?
One one
D0,
one.
ma'am.
D0. That means D0 value will become 1. This D0 will become true. Right? D0 will be true. Remaining all are zeros.
Zeros.
Because, yes,
The
zeros. Next. Again E equal to 1. The next one is 0, 0, 1. So which output will be active?
D1,
D1
ma'am.
ma'am. D1 ma'am.
D1 is 1. Yes, remaining all are
Zeros.
zeros. Remaining all are zeros. Next, like that, next one 0, 1, 0,
D2 ma'am.
0, 1, right. D2 will be active, remaining all are zeros. Next one
D3 ma'am.
1, 0, 1, 1. Next combination is 0, 1, 1, which is equal to D3. So D3 will be active, remaining all are zeros. Next, again 1, 100. So D4 will be active, remaining all are zeros. Next 1, 101. So D5 will be 1, remaining all are zeros. Next one 110, 0, and here 110 represents D6, remaining all are zeros.
Zeros.
Remaining all are zeros.
Zeros.
Next for the last one, all ones. D7 is 1,
D7.
remaining all are zeros.
Yes, ma'am.
Okay. So this is the circuit truth table. All of you note down this one.
Yes, ma'am. ఈ కింద
Isma, is it completed? Okay, think in logical manner, then the drawing of the circuit will become easy. There is nothing to worry. The simple logic you need to connect based on the numbers. Okay, all zeros means all the inverted gates. Okay, 0 represents after inversion and 1 represents normal input. Okay, completed. Shall we move to the next one? Isma.
Yes, ma'am.
Hmm. What about others, ma?
Completed, ma'am.
Yes, ma'am. Completed, ma'am.
Right, right. Hmm. Next, NAND gate decoder. NAND gate decoder. So with the NAND gates also you can construct the decoder. And here we will see the example of 2 to 4 line decoder. Okay, 2 to 4 line decoder. So 2 to 4 lines, how many inputs will be there and how many outputs will be there? No?
Two inputs, four outputs, ma'am.
Right. So I can take the inputs as A1 and A0. What are the outputs will be? What are the outputs will be, man?
D0, D1, D2, D3.
Right. So here I can take D0, D1, D2 and D3. And next one more is here. These are the outputs of which gates, one? NAND gates. Here we are using the NAND gate, no? So these are the outputs of NAND gate. So this is first NAND gate, second NAND gate, third NAND gate, fourth NAND gate. Okay. Now, so A1 and A0 are inputs. If the system, if the circuit works means you need to have the E value. Okay. If you want to activate the circuit, you need to have the E value. So this is the reverse operation of AND gate because we are constructing with the help of NAND gates. So E will be inverted. E will be inverted and connected to all the gates. E will be inverted and connected to all the NAND gates. Why we are inverting means here this is the output produced after the reverse operation of AND gate. For the first circuit, what we have given, we have supplied E directly. Supplied E directly. But here what we are doing, we are supplying E after inverting. Okay, after inverting. Next thing. So this is D0. When D0 will be active? D0 will be selected at The combination, input combinations ఏంటమ్మా? If you get the D0 output, what are the input combinations will be?
0 0.
0, 0, right, 0, 0. So I'm taking A1, okay, A1 complement. Next, A2 complement. Right, next one is D1. For D1, what is the combination you will get, ma? What is the combination
0
you will
1.
get here?
0 1 1.
0, 0, 1. So I'm taking here 0. And what about 1? A naught value is 1. A naught value is 1. Okay, next. What is the next combination you can have?
10.
1 0, ma'am.
1, 0. 1 is related to A1. So I am taking from here. Next, 0 is related to A naught. Right. Next one. What is the next one, ma'am? 1, 1,
1.
1, 1, 1, 1. So I'm continuing with this as A1. And what about A0? I'm taking from here. Okay. So this is the circuit. This is the decoder for 2 by 4 with the help of NAND gates. With the help of NAND gates. So the truth table. Now we will write the truth table. Truth table. Truth table consists of E, A1, A0. Okay. E, A1 and A1, A0. Next one, outputs. What are the outputs here? D0, D0, D1, D2 and D3. Now tell me, if E equal to 0, what happens? If E equal to 0, what happens?
No inputs, ma'am.
See here, E equal to 0, what will happen here? Inverted 1. 1 means power will be supplied, circuit will be on. Here we are giving the inverter for E value. So E equal to 0 means it is in working mode. If E equal to 0, it will take the inputs A1, A0. So if A1, A0 both are zeros, then which output will be produced?
D0, ma'am.
Right.
D0, ma'am.
Remaining all are yes.
Zeros.
0.
Remaining,
Yes.
yeah. Remember this one. Here we are not using the AND gate, NAND gate. So here D0 will become 0. Next all will be in the 1. Okay. Reverse. For the AND gate, the output is, when the output is active, we are representing it as 1. But for the NAND gate, we are representing it as 0. Next, E equal to 0, A1 and A0, that is 0, 1. Which will be active, ma?
D1.
D1 is active,
D1.
remaining, D1 is active, remaining all are ones. Be selected. Next, 0, 1, 0. 1, 0 means D2, here it is 0, remaining all are ones. 0, 1, 1. So 3 is selected and remaining all are ones. Next, if E equal to 1, what happens? If E equal to 1,
Remaining all 0, ma'am.
so no inputs will be supplied. No inputs will be supplied. All are ones. All are ones. Right?